I'm Yue Shanguo. I'm the first-year master student in Applied Financial Mathematics. I took the Financial Data Mining with Dr. Zhu this semester. I do like this course. During the course, I learned a lot about the financial data mining, processing, and the algorithm, such as the regression model, decision trees, and neural networks. Also, I improved my graphic skills using the MATLAB, React, and Python. I do like using the metrics in MATLAB, which helped me a lot in my internship and future job. I would recommend this course to other students. Also, I need to thank my teammates, Yin Chen and Yuchen Lu. They did a lot of help. They are supportive and helpful. We did have a great time doing the homework. Okay, let me introduce our final project. The topic is the real-time risk management system. I will introduce the main theory, value at risk.
Hello everyone, my name is Yin Chen. I'm the first year master student in Applied Financial Math. For this semester, I'm taking the Financial Data Mining with Big Data with Dr. Zhu. I really learned a lot from it. First of all, since it's a financial data mining course, I learned financial models, such as cost function and gradient descent algorithm, to analyze data in financial perspective. And also, it's a big data course. I do learn a lot from it, such as data mining. Here, I would like to say thank you to my teammates, Yue Shan and Yu Chen, who are really collaborative and supportive all the time. Since all of our work are based on the team collaboration, it's really nice to be the teammates with them. Our final project for this course is real-time risk management system. It's really interesting, and I hope you guys will enjoy it. Thank you.
I'm Yuchen Lu, the first year master student in actuarial science. I really enjoyed Dr. Du's data mining course. My undergrad major is information and computing science, so I'm quite familiar with MATLAB and some other programming languages like C#, C++. But for me, data mining and machine learning is still quite new. I recommend Dr. Du's class because his class covers comprehensive content, and he himself is very helpful, very patient, always willing to help us deal with some problem.
So here is our final project, real-time risk management system. The main theory of the system is value at risk. We use value at risk to measure potential loss in value of the traded portfolios from adverse market movements over a specified period. We map the risk in the individual investments in the portfolio to more general market risk when we compute value at risk, and then estimate the narrow based on this market risk exposures. There are generally 4 steps involved in this step. The first step requires us to take each of the assets in a portfolio and map that asset onto simpler, standardized instruments. In the second step, each financial asset is stated as a set of positions in the standardized market instruments. Once the standardized instruments that affect the asset or assets in portfolio been identified, we have to estimate the variance in each of these instruments and the covariance across the instruments in the next step. These variance and covariance estimates are obtained by looking at historical data. In the final step, the value of risk for the portfolio is computed using the rates on the standardized instruments computed in step 2 and the variance and the covariance in this instrument computed separately. Using the historical data in the past 30 days, we compute the mean and variance of the stock price given by law of large number. The laws of stock price should follow the normal distribution with historical mean and covariance. Our project, we set alpha equals to 95%. Term is 30 days, which means that there is a 5% probability that the portfolio will fall in value by more than 95 quintile over 30 days if there is no trading.
Hi, this is In. Right now I'm going to talk about our code using in our project. There are two parts of our code. The first is the Python code to get the data. The second is the R code to perform the data analysis. In here, this slide shows the Python code to get the data from the Google Finance API. And we actually define a function named getStockPrice with Q, I, P, F as inputs. Well, in here, Q is the stock symbol. I is the time interval. Here we choose interval of 600 seconds. In other words, we would like to get the data for every 10 minutes. P is the number of period. We choose the data in the past 30 days. F is parameters. We choose the closing price in here. The function in here actually reads the symbols received in a CSV file and collect the data for corresponding symbol and stocks and save the desired data in another CSV file. And then we would like to process the data by using our R code. We read the data for the CSV file received before, and for some cells of the data, we found that instead of the value, it shows the time zone offset equals to negative 214 instead of the real data. So we decide to treat it as a missing data and remove it and restore the data as a numerical matrix. And then we split the data into two parts. The first one is training data, which contains the 75% of original data, and the rest of then is the testing data. And we would like to compare the training and testing data. In order to do that, we decided to compute the mean and standard deviation for each stock of training and testing, and then we would like to compare them using the student t-test for the mean and the f-test for the standard deviation separately. And here is the result for student t in the first row, and the second row is the f-test for the result. And the value of t-score and the f-test indicated that there is no significant differences in both mean and the standard deviation for training and testing data. Therefore, the two datasets has distribution with similar mean and standard deviation. Hence, we can measure the risk by normal distribution for the entire data. And here is how we compute our risk measure. We use the code in here to compute the mean for entire data and the standard deviation for entire data, and we compute the price at the 75 quintile for each stock by fitting the normal distribution for entire data. The black box shows the result of it for each separate stocks, and for this result we can know the possibility of losing exceeding the price listed above for the corresponding stock is not greater than 5% in the next 30 days. And for the further discussion for our result, we can see that Google has the highest possible loss, and Yahoo has the lowest possible loss. This high value of possible loss for Google does make sense, since the price of the Google stock is very high. In order to maintain its liquidity, the Google would like to increase the share outstanding, which would reduce the price per share of its stock and increase the possible loss for shareholders. Next, Yuichen will talk about how we actually run our code in our computer, and this is the presentation for now. Thank you so much. Have a great day.
We just copy and paste in the code. So it will build a CSV file that store our data. Now let's see if the file is actually built. Now we can see the data here. Now let's open it. Now we can see the data. Now let's open Putty. I've already saved the host name and port. We load it and open. So we can log in using our Night ID and password. Then we run R. And you should copy the code here, but notice that the directory is on my local computer. It's not on HPC. So first we should copy the data file onto HPC. So we need to use Windows Security Copy. Now let's open it. As before, we log in using our Night ID and password. So now we just copy the data file to HPC. Then copy the directory and change it in the code. Then we can copy the code and run in HPC. So we can see the value at risk for the 6 stocks. And if we want to compute the value at risk for other stocks, we just need to change the symbol list file. Here, we just need to change or add other stock symbols.
This is the end of our video for our project of real-time risk management system. I hope you guys will enjoy it. Thank you so much.